Alright, in this video we're going to talk about some applications of indefinite integration or anti-differentiation, either way, however you like. So we've got the rate of growth of a population of fish is given by this function dp over dt equals 150 root t. For all values of t between 0 and 5 years, the initial population was 200 fish, so we want to find the number of fish at 4 years. Okay, so we've got a couple clues in this problem. The first is the rate of growth of the population of fish. Remember, anytime you're talking about a rate of change, instantaneous rate of change, that's talking about a derivative. We also have this obvious clue, dp over dt, is also indicating that we're talking about a derivative. So what this function is giving us, or what this equation is giving us, is the derivative function p prime of t, and that's 150t to the 1/2 power. So we know that this is a derivative function, so we need to get back to our parent function to find the population of fish at any given time. So p of t is going to equal the indefinite integral of 150t to the 1/2 dt. So we need to work this thing back up to the parent function. We're going to use our constant multiplier rule and say 150 times the indefinite integral of t to the 1/2 power dt, and then we're going to use our power rule, 150 over times 1/2 plus 1, then t to the power also of 1/2 plus 1, and then of course we have to always add our constant of integration plus c. Alright, so we're simplifying 150 times, let's take a look at this denominator. 1/2 plus 1, well that's 1/2 plus 2 over 2, that's going to be 1 over 3 halves, and when we're dividing by a fraction within a fraction, we know we multiply by the reciprocal, 2/3. So 150 times 2/3 t, again we've got 1/2 plus 1, we know that's 3 over 2, plus c. Alright, we can simplify this 150 and 3, so we get 50 and 1 in the denominator, and we end up with a parent function of 100t to the 3/2 plus c. Again, this is the parent function. Alright, so now that we've got our parent function, we can start looking at, well, we can almost start looking at finding fish at 4 years. But the problem is, even if we plugged in t at this point, we have a couple of unknowns. We've got our p of t is unknown, our t is unknown, and our c is unknown. So we need to look for some other clues. And we've got two. We've got the initial population, and how many fish that initial population was, 200. So this means that at t of 0, our population was 200. Alright, so we call this a boundary condition. So a boundary condition is a condition that helps complete the function for this specific situation. We know anytime we take the integral, we have this constant of integration c, and it just hangs out there. We don't know what it is until we get some of these boundary conditions. So we're going to use these to help us get the full parent function. So we're going to have 200 equals 100 times 0 to the 3/2 power plus c. Do some nice basic simplification, and we get c equals 200. So now we can say our new parent function is 100t to the 3/2 power plus 200. Now this is specific to this fish population. It's got the boundary conditions of this fish population. So now we can finally find the number of fish at 4 years. So we're just going to take that 4, plug it in for our t, and we get p of 4 is equal to 100 times 4 to the 3/2 power plus 200. Simplifying, we get 1,000 fish, and that's how many fish we have at 4 years. So using the boundary conditions to help us complete the parent function. Let's look at another one. Alright, so I'm going to jump ahead. The curve y equals f of x passes through the point 32, 30. The gradient of the curve is given by f prime of x equaling to 1 over the root of the 5th root of x cubed. We want to find the equation of this curve. Okay, so again, we know that the gradient or the derivative is the derivative function of the parent, which is the equation of the curve. So we need to find, if we're looking at f prime of x, rewriting it, that's going to be x to the negative 3/5 power. And we want to get to f of x. And so we're going to take the indefinite integral of x to the negative 3/5 dx. Okay, so using our power rule, we know that's going to be 1 over negative 3/5 plus 1 times x to the negative 3/5 plus 1, and then of course we're going to have plus c. Alright, so we have 1 over 2/5 times x to the 2/5 power plus c. Alright, so we need to take care of this, this complex fraction, and we have 5 over 2x to the 2/5 power plus c. Now, we're going to look at 3230. This is also considered a boundary condition. Even though it's not quite the same word type problem like we looked at with the fish, it still is going to help us find that value of c. So we're going to use this 3230 with our function. So f of 32 equals 30. So we're going to plug that in. 30 equals 5 over 2, 32 to the 2/5 power plus c. Solve for c. 30 equals 5 over 2. Let's see, 32 to the root 5 is 2. 2 squared is 4, so we got 4 plus c. Simplifying, and we get 30 equals 10 plus c, so c is going to equal 20. Alright, so now we have our parent function here, and that is f of x equals 5 over 2x to the 2/5 power plus 20. And there is our parent function. So what we're doing is we're basically going to be looking at given points, given information to help us find the value of c so we can come up with a complete parent function for this any given derivative function. So I hope that helps, and we'll talk to you soon.